ArcSan is now digital.ai. Join us at our booth in the virtual expo hall to learn how our app protection, white box cryptography, and threat analytics solutions can help you stay ahead of the evolving threat landscape.
Hello everyone. Thanks for having me here. So my name is Rundong Liu from Pinterest. It's really exciting to have this opportunity to share our research from Pinterest. So today I'm going to talk about detecting social media botnets with linkage analysis and machine learning. So before we get started, let me give some introduction about myself. So my name is Rundong. I'm a senior machine learning engineer in trust and safety team at Pinterest. So trust and safety team is like the integrity team, and our responsibility is to detect abusive users, unsafe content, basically to make Pinterest safer. And here I have been leading the effort building machine learning solutions for spam and anti-abuse. Before this, I worked at Shape Security as a research scientist, where my research was mainly around detecting automated web attacks. My first job was at FireEye, focusing on malware analysis and email security. So in my daily life, I enjoy surfing at Pacifica and Santa Cruz. I also have a cute cat called Andy. Okay, so that's all about me. Let's get it started with the topic. So the outline of today's talk contains 3 parts. First, we'll give an introduction about social media spam. We'll talk about what is social media spam and particularly talk about the spam botnet problem, which is a major threat for social platforms. And second, we'll try to build a botnet detection solution. We'll borrow a concept from crime investigation, which is the case linkage analysis. From there, we'll try to build 2 machine learning models. The first one is an unsupervised behavior clustering model, and the second is a semi-supervised model based on label propagation. And the last part is around spam defense automation. We'll talk about how to build the machine learning pipeline based on the models we have introduced, and also show some example applications in our spam detection platforms. So without further ado, let's dig in. The first part is about introduction. So with the rise of social media, social network has been affecting our lives much more than before. The recent analysis shows that in 2005, there are only like 5% of US adults had access to social platforms. But now in 2019, more than 79% of us are using it every day. And the average time we spend on social platforms is also rising year by year. And in 2019, the most recent research shows that modern adults usually spend 2.5 hours on social platforms every day. So social media has become a very good target for make profit online and also attracts a lot of spammers and hackers. So there are various ways spammers can make profit from social media platform. They will distribute malware, gambling, and porn sites. They also share excessive ads or affiliate links and utilizing the pay-per-view or pay-per-click model to make money. We have also seen spammers try to promote their e-commerce scam sites. When users actually make a purchase on the site, they never get the product delivered. Spammers also sell fake accounts, followers, or likes to satisfy people's ego. We can see that most spams are all around user clicks. More traffic means more money. We have also observed the different types of spammy behavior. Spammers will intentionally spread malicious links to get malware installation. They also share excessive clickbait content to trick for user visiting. Bulk messaging and following is also a strategy for spam, since there are always some users who are so curious that they cannot control themselves from clicking the links a stranger provides. Some smart spammers leverage fake engagement to gamble the ranking systems so their content could rank higher in home feeds and get more distribution. A successful spam campaign usually involves two important factors. They need to attack at scale and attack with automation. Of course, the manual fraud is far from fulfilling the need for excessive content distribution. So next part, I will talk about some statistics that are specific to spam on Pinterest. If you have ever used the Pinterest app, you should be familiar with Pinterest product design. So we allow users to upload an image or video to create a pin. And then with the pin, users can also attach a link. When we see the pin and get interested, we could click through the pin and reach the landing page and find more interesting stuff. So this design is to provide a more convenient way for users to share inspirations and find out what they love. But also this model gives spammers a proxy for link spamming. So most common types of spam we are observing are from misdirected pins, which means spammers will copy and paste the legitimate user's content and change the landing page to a spammy link, then redistribute it. Lots of link spamming is around ads and affiliate links or malware links. On the right side, you can see the alert box we usually show to users when we detect a spam domain or link underneath the pin. Ever since Pinterest has launched, we have already detected like more than 500 million accounts because of spam. That's about like 30% of all accounts ever registered. And the number is even more than our monthly active users. So during our long-term fighting against them, we found that most of the spam accounts are from bots. So spam botnet is a major threat for social media, but it is nothing new. If we quickly do some online search, we can easily find some commercial software for social botnet on the market. Well, they provide lots of convenience to control bot accounts to do the social marketing or just for spam purposes. When we actually check their advertisement, we can see they provide like a lot of features like real browser simulation, so you can avoid front-end detection. And they also provide like pattern obfuscation features like random delay. And the softwares also provide like proxy support. So if your IP gets blocked, you can easily mutate. And most importantly, they allow users to control like multiple accounts. You can actually import a lot of bot accounts just using a text file with username and password in each line. Another usage of spam botnet is the spam as a service. So instead of purchasing all the infrastructure to launch a spam campaign on your own, you can just spend some money to buy some spam services. And the spam service on the market usually accepts your content or your link, and they will do the heavy lifting for you. And you just wait at home, and they will generate visitor clicks for your spam sites. As we can see, spam botnet has so many advanced features. Their behavior are randomized, and it is fully automated. And they leverage a lot of accounts and IP to bypass the read limit. And they can also be very fault tolerant, which means they can quickly refill accounts or IP addresses once some of them are blocked. This creates a lot of challenges for our detection. Sometimes we observe that each spam account may only have several actions in their lifetime, so the event log is not sufficient enough for a high confidence detection. And since most of the traditional rule-based defense method mostly look at spam accounts individually, it can be difficult to correlate different accounts within the same campaign and see the true volume of the spam attack. So in order to detect this, let's jump into part 2 to build a spam botnet detection solution. We'll first try to borrow a concept from crime investigation. which is called case linkage analysis. It is also referred to as linkage analysis. It's the process of determining whether there are discrete connections or distinctive behavior factors that associate unrelated cases by means of crime scene analysis. It is also referred to as linkage analysis. It's the process of determining whether there are discrete connections or distinctive behavior factors that associate unrelated cases by means of crime scene analysis. The idea is to identify crime committed by the same offender. I'm sure that most of us have seen crime investigation movies or documentaries when detectives analyze multiple crime scenes. When they find too much evidence similarity in different crime cases, they may reach to the conclusion that those cases are committed by the same serial offender or serial killer. And during investigation, they will collect evidence like DNA or fingerprint, shoe print, common usage of a weapon, or common offense location. So they are very good evidences that can correlate different crime scenes and help investigation. And similarly, we can adopt this methodology for botnet detection, since naturally, cybercrime is also a type of crime. The idea is to associate bot accounts with their behavior evidence and discover accounts controlled by the same spammer. So there are clearly some advantages from this method. We are able to identify bot account in groups. We can take actions in bulk since we are detecting them in bulk. And we can actually capture the whole campaign by aggregating all the spam accounts and their behavior. So the key point of performing linkage analysis is to build the bot linkage. So the bot linkage can be defined as behavior similarity. So it's basically try to find properties that are commonly shared by bot accounts, but rarely shared by legitimate users. Let's say if account Alice and account Bob. If Alice and Bob share some behavior similarity X, Y, and Z, then we believe based on intuition that the likelihood of them being controlled by the same spammer is very high. Then we add a bot linkage between them. So there are a lot of ways to define their behavior properties. We can include like network properties like IP address or user agent. We can also leverage like profile-related features like email, user description, profile pictures. We can also involve like engagement-related features, like if two accounts have posted the same content, comment, if they have liked the same stuff. Here, I'll give an example of the bot linkage and try to analyze the properties two users can share and the likelihood of them being connected. Let's say Alice and Bob, they're both active on Pinterest on the same day. So the likelihood of them being connected is really low here because there are a lot of users using Pinterest each day. And what if they also liked the same pin? Well, this is also low because for some viral pins, a lot of users could like it too. So what if they also log in from the same IP address? Well, intuitively, this makes the likelihood of them being connected kind of higher, but there are still some edge cases like public Wi-Fi address where users could share the same login IP. And then move forward, what if they have also uploaded the same image with the same hash? Well, intuitively, we'll believe that this will make their connection probability higher because this really happened on legitimate users. And lastly, what if they also post with the same text? Like follow us today, click the link below. Well, based on our experience, this kind of common behavior rarely shared between legitimate users. And at this point, we believe that the likelihood of Alice and Bob are connected are very high. So it is worth noticing that different linkage definition could result in different types of spam behavior detection. So from there, let's try to build an unsupervised learning model. So the first step is to build the linkage network. The idea is connecting two accounts if they have a bot linkage between. And first, we will collect all the accounts, and we should try to connect every two accounts if they have a bot linkage. Then we will have an account connection graph with each account as a node and shared bot linkage as edges. With the graph, we can start to perform like graph-based clustering. And after community detection, we will find there are different clusters of accounts. And we will also find that a lot of legitimate users will remain as dangling points in the graph, which means they are not connected with each other, since legitimate users rarely share the bot linkage with other users. And from there, we'll look at the large clusters and try to label the botnet accounts. If our bot linkage definition is strong enough, it is most likely that the larger the cluster, the more spammy it could be. Here, we're using behavior-based graph learning. So the advantage of it is we have better visualization because it's graph naturally. We can visualize it just by plotting the edges and nodes. And from behavior-based method, it is completely content agnostic, which means we don't really care about what users are posting. We can correlate just by their behavior similarity. And this method is highly debuggable, which means if you find some false positive cases, you can quickly dig into the graph and find out what is causing the false positive and fine-tune your model. And this method does not require any labels at all. But in reality, during our long-term spam fighting, we do collect a lot of labels. So how can we utilize those labels efficiently as well? So next part, I will introduce a semi-supervised model. And before that, let's take, sorry. Can I start over? Before moving forward, let's take a look about another crime investigation strategy. So when we watch mafia-related movies or news, we often notice that during a mafia takedown operation, the FBI or the government normally don't arrest non-important suspects, even though they have collected strong evidence that they are criminal and they can make a charge. But instead, they start to monitor those suspects' behavior and hunt for the boss or more members, and they hope to find out the clear mafia structure so that they can take it down altogether. Well, they look for evidences like social connections, transactions made, or their common home locations. And similarly, in social spam detection, we could also take the similar steps, but with a different concept, shadow ban. So what is shadow ban? Shadow ban means when we identify some bad actors, instead of deactivating them immediately, we silence them. So when we shadow ban an account, the account is still alive for posting. You can still engage with the account by posting stuff, like stuff, but the content generated by this account is no longer available for discovery services, which means home feed will not pick up the content from this account, and this will have very minimum impact for other users, and the content will not get distributed. So the advantage of shadow ban is just like what we introduced during a mafia takedown operation. We can monitor silenced accounts and track other accounts with similar activities, and this will help us detect more spam accounts. Here, we'll try to leverage the account connection graph we have previously, and also utilizing the shadow banned accounts. We first build the linkage graph, and from there, we'll mark the shadow banned accounts that were previously identified as bad. And using some predefined rules, we can start to propagate the label just to mark the accounts connected with the shadow banned accounts as bad. We can then try to iterate this approach until the graph converge. And from here, we gather more positive spam accounts just from the limited shadow banned accounts from the previous graph. And of course, this method may involve some risks. The first one is the cascade effect, which means one single false positive may cause more. Let's say we mislabeled one account as a shadow banned account just by mistake. And somehow this account is connected with some other users. Just by label propagation, we could potentially introduce more false positives because just the bot linkage they have around the shadow banned accounts. And the second one is the serial spoilers. If spammers figure out this algorithm, they can intentionally try to ruin our detection method. Some spammers intentionally try to copy paste the content from good users. And if we just use the bot linkage, if we just define bot linkage by behaviors similarity, this could result some good users being marked as bad because of the propagating labels. So there are some possible solutions from here. First, we can limit the propagation iteration steps and restrict the false positive from being distributed too much. And second, we can also define a more robust bot linkage definition by introducing some non-forgery properties. For example, a spammer may intentionally copy content from good users, but it is very hard for them to reuse the same user agent or IP address from the good users. So by introducing those non-forgery properties when defining your bot linkage, we can limit the chance of propagating wrong labels. So the third part, we'll talk about how to build a spam defense automation. So this slide shows the pipeline we have for the machine learning models. It contains 3 stages. So the first, we need to collect features and by processing the logs. We'll dump the event log from user frontend into a relational database. Basically, it's a column-based database with different features. We'll also try to build behavior profiles for each account. After we have all profiles for all accounts, we can start to build the bot linkage. We will cross-join account profiles and count every 2 accounts if the link between them satisfies the linkage definition. And after that, we will have an account connection graph in edge list format. Once we have the graph, we can perform graph learning algorithms. We will perform graph-based clustering. And after community detection, we will have different clusters of accounts. So after this stage, we will have each account assigned with a unique cluster ID. So from there, we can start to take a look at the large clusters and maybe take some action. We'll most likely classify bot clusters by looking at the cluster size and deactivate the old accounts within the large clusters. And agents and analysts will keep monitoring this cluster results and try to see if there's any incident response needed. And the whole pipeline, we leveraged several open source libraries like Kafka and Spark. And for graph-based learning algorithms, we used GraphX. So I will introduce some example applications we have in Pinterest platform for spam detection. So the first one is the fake account spam detection. The heuristic is simple. We have observed a lot of spammers trying to bulk register fake accounts, and they either resell it or launch the bot spam campaign on their own. And normally they will register in the same time period with similar profiles. So here we will define the bot linkage as similar sign up time and similar profiles. We'll first gather all the accounts registered in the similar time period and perform a locality-sensitive hash and map each account into a different bucket. And after that, we will connect every two accounts in the same bucket and get the connection graph. Then we repeat the process we have introduced and get large clusters with similar profiles. And from there, we'll look at the large clusters, and most likely they are from bot registrations. So here is a detection example of this machine learning model. What I have shown here is a cluster of porn-related accounts. As you can see, they have very similar profile description. We have also observed that spammers are intentionally mutating their text description to avoid rule-based detection. So next, I will introduce the pin-create botnet spam detection model we have. The heuristic is legitimate users are pretty random and unique. They really have similar behavior, like posting the same content multiple times. And normally those behaviors usually belong to like bot accounts. And here we'll define bot linkage as two accounts have similar active time, and they also post the identical image or text multiple times. And from the model itself, we detect a lot of pin create botnets. And here I will show just one example we have here. On the right, you can see the connection graph. It contains 54K nodes as accounts and 900 edges as two users have posted similar content multiple times. It is worth noticing that all legitimate users, most legitimate users are dangling in the graph, so I have removed them. And when we take a deep look into that, we found that it actually includes several malware campaigns that were active last year. So this helped us to detect several campaigns without even digging into what content they're using. And our analysts also analyzed the result and quickly patched a rule to stop the campaign. Okay, I think that's all I have today. So I have several key takeaways. So in this talk, we adopted several crime investigation strategies for cybersecurity defense. So this is intuitive because cybercrime is a crime as well. So the methodology will work here as well. And we also leveraged the behavior analysis to build linkage graph and use graph learning for spam detection. So this method is behavior-based and content agnostic. This enables us to identify new attacks pattern quickly in the wild. And the same method would also apply to other online fraud detection, like money laundering detection or detect distributed denial of service. And lastly, data science and machine learning are great tools for automated cyber defense. I'm sure it will generate a bigger impact for the security industry in the future. Okay, I think that's the end of the talk, and thanks a lot.